This episode was made possible by the Vsauce 3 Patreon. To support Vsauce 3 and get early access to videos, wallpapers, live hangouts, and more, sign up at patreon.com/Vsauce3. I love you. Pew pew. Vsauce. I'm Jake, and nitrogen is a gas until it gets really cold. Then it turns into this. Liquid. In this state, it has a temperature around minus 196 degrees Celsius. And these drops that are shooting off trailing vapor, well, they're literally boiling away into nitrogen gas at room temperature. And because nitrogen has a high evaporation expansion ratio, each drop expands to 700 times its volume in gas, even though it was just a tiny drop. Using a thermal camera, we can see just how drastic the temperature change is. Once our container is filled with liquid nitrogen, it entirely becomes this deep blue. You can even see the liquid nitrogen boiling away on the surface. Whereas in real life, or with a regular camera, we can't see through the gas at all. But we are here to levitate an object, so what does liquid nitrogen have to do with magnetic levitation? Because you can make magnets levitate without it right now. And to demonstrate this, I'm going to use Ink's levitating rings, which is a fun product that Michael, Kevin, and I made for the Curiosity Box. There's a link down there in the store if you want to get your own, or you can use any two magnets that you have at home. Now, let me show you how this works. If these two magnets have like poles facing each other, they repel each other. It is the same principle for how maglev trains work. And the opposite occurs if we flip the magnets around. They're attracted to each other. But what we're doing here is not regular magnetic levitation or maglev. It's superconducting maglev, which is different. First of all, let's discuss superconductors. A superconductor is a material that exhibits two incredible properties when it is cooled below a so-called critical temperature. The first is that they have zero electrical resistance. But more important for our purposes is the Meissner effect, which causes a superconductor to completely expel magnetic fields when they enter their superconducting state. What that means is that a superconducting material will actually levitate over a magnet, even though the material itself is not magnetic. Now, this is our superconductor, a small disc made of yttrium barium copper oxide. Actually, in this whole thing, the superconducting material is just a tiny sliver of crystal grown on top of a stainless steel core and covered by a protective layer of silver and aluminum. And when I say a tiny sliver, it really is. It's just 3 microns thick, 30 times smaller than the thickness of a human hair. And if I were to put a magnet next to it, well, nothing happens because it will only levitate when it's below that critical temperature, which is why I drowned it in liquid nitrogen. One of the most amazing things about superconducting levitation is what you see here. Not only does the disc hover above the track, but it can hover below it as well. In fact, we can shape the track any way we want, and the disc zooms along at exactly the same height, no matter its orientation, with no friction or resistance. That's due to a phenomenon called flux pinning or quantum locking. Basically, while the Meissner effect means that any superconductor will expel magnetic fields, if you intentionally introduce some imperfections into that material, then a little bit of the field can penetrate it in discrete quantities called flux tubes. Inside each of the tubes, essentially a tiny bit of the magnetic field gets trapped inside the superconductor, pinning it in place. And what I mean by that is that our superconductor, our disk, is quantum locked to the magnetic field generated by this track. That's what allows our disk to go back and forth and upside down without falling off or flying off either end. It also is what allows us to minutely adjust the superconductor's orientation. Now, to be entirely honest with you, I don't know how to end this episode, so here is some more cool levitation footage set to the song Flower Duet from Delibes' opera Lakme. And as always, thanks for watching.